When we're describing an exponential model, one of the challenges is describing the multiplier. One of the ways that we like to describe multipliers, in general, one of the ways that we talk about multiplication in English, is by talking in terms of percents or of percent change. So here's an example where we describe the situation just in terms of a percent. Every year, about 65% of all aluminum used is recycled. So that means 65% of the aluminum gets recycled and continues to circulate. If 50 kilograms, or 50,000 grams, of aluminum enter circulation this year, so we just want to think about that 50,000 grams of aluminum, write an exponential function describing the amount A, so we're going to call our function A, of this aluminum in grams that remains in circulation after T years. Well, to find 65% of some amount, right, percent means out of 100, so we divide by 100. To find 65% of some amount, we multiply by 0.65. So our multiplier is 0.65. We start with 50,000 grams of aluminum. So our A naught is 50,000. The amount that remains in circulation after T years, well, every year we keep 65% of it. So every year we'll multiply by 0.65. After T years, we'll have 50,000 grams times 0.65 to the T. So when we're just told what percent we want to actually use, we just use that percent in our equation. This next problem has subtly different phrasing that you might miss if you're not reading all the words. So this problem said 65% of all aluminum is recycled. That means that we keep 65%. The next problem says the population of a small town decreases by 4%. And this phrasing, decreases by 4%, is the key phrase. The population of a small town decreases by 4% per year. This year the population is 13,850. We want to write an exponential function describing the population T years from now. So, if the population decreases by 4%, that means, well, it starts out with 100%, right? We start out with the whole population, and we lose 4%. So 96% of the population remains, right? If we lose 4% of the population, that means we have 96% left. So each year we multiply by 1 minus 0.04 is 0.96. Our multiplier is 0.96. The starting population, the population this year is 13,850. So that's the value of our P naught, 13,850. We found the multiplier and our starting value. Our function is 13,850 times 0.96 to the T. Okay, so the key phrasing here was the population decreases by 4%, as opposed to 65% is recycled, 65% stays. here 4% goes. Now, if the population can decrease by 4%, well, then something could also increase by some percent. In this example, the value of a certain stock increases by 12% each year. So then we're told the current value of the stock, but let's deal with this increases by 12% first. If the value increases by 12%, it starts with 100%, and then it gets an extra 12%. So we end up with 112% of the original value, right? We end up with more than 100% of the original value because the value is increasing. Each year we multiply by 1 plus 0.12 is 1.12. Our multiplier is 1.12. We were told that the value of the stock started. Let's go back and find that. The value of the stock is currently $350 per share. So our V0 is 350. So that means that V of t will have 350 times. Our multiplier is 1.12. We raise it to the t power. Notice, if we have a percent change, we need to do some addition or subtraction. If we have a percent increase, we add that to 1, as we did here. 1 plus 12%. When we had a percent decrease, we took 1 minus 4%. So when we had a percent decrease, we subtract it from 1. And that 1 represents 100%. We start with 100%. If we get some more, we add that to 100%. If we get less, we subtract that from 100%.